Good morning, students. In the last lecture we have discussed elastic collision in one dimension. One dimension means the one dimension means the body is moving along a straight line path. Body is moving along a straight line path. Now we have to discuss inelastic collision in one dimension. What is inelastic collision? In inelastic collision, we assume that body A is moving with the velocity u1 and B is moving with the velocity u2, right? And after collision, what happens if after collision the body A starts moving, this is of mass m1, m2, A must start moving with the velocity v1 and B starts moving with the velocity v2, right? And in inelastic collision there is some loss of kinetic energy that we have discussed. So here, according to conservation of momentum of bodies before collision, is equal to after collision. What is this? This is m1 into u1 plus m2 into u2 is equal to m1 into v1 plus m2 into v2. Right? This is equation number 1. Now here the conservation of kinetic energy is not obeyed because this is in inelastic collision. So here conservation of kinetic energy is not obeyed. So how many unknowns are there if you want to calculate v1 and v2? You have one equation, right? We want to calculate v1 and v2, right? These are the two unknowns. So for finding two unknowns, in maths you have studied, if you have two unknowns, you require how many equations? Two equations. But here you have one equation. So one of the unknown we have to find out. One of the unknown quantity we have to find out experimentally. Quantity we have to calculate. कैसे कैलकुलेट करना पड़ेगा आपको? We have to calculate experimentally, right? v1 and v2 are two unknowns, and so one equation is there. So one of the parameter we can calculate from this equation and other we have to calculate experimentally. Now the next is perfectly inelastic collision in one dimension. Perfectly inelastic collision in one dimension. इसमें हमने डिस्कस किया था इन परफेक्टली inelastic collision in one dimension. After collision, both the bodies stick to each other and they start moving with the same common velocity. This is A moving with the velocity u1 and B is moving with the velocity u2. After collision, both the bodies stick to each other and they start moving with the common velocity. This is A and this is B, and both start moving with the common velocity v. Now according to conservation of momentum, we can say momentum before collision, this is before collision, is equal to momentum after collision. m1 into u1 plus m2 into u2 is equal to m1 into v plus m2 into v. So you can write m1 into u1 plus m2 into u2 is equal to v into m1 plus m2. What is v? V is the common velocity with which m1 u1 plus m2 u2 divided by m1 plus m2. What is v? This is the common velocity shared by two masses. This is common velocity of these two. Now here we have to prove what is the loss of kinetic energy. आप इस collision में perfectly inelastic collision में क्या calculate करेंगे? Loss of kinetic energy. You can mark this as equation number 1. So now next is to find the loss in kinetic energy. आपको लॉस इन काइनेटिक एनर्जी फाइंड आउट करना है. सो वी हैव टू कैलकुलेट व्हाट इज द टोटल काइनेटिक एनर्जी बिफोर कोलिजन बिफोर कोलिजन कितना होगा? दिस इज, ये हमने अभी लिया, u1 और u2 वेलोसिटी से मूव करें, दिस इज हाफ ऑफ m1 इंटू u1 स्क्वायर प्लस हाफ ऑफ m2 इंटू u2 स्क्वायर, m2 into u2 square. What is the total kinetic energy after collision? Let it be E1. Total kinetic energy after collision is E2 is equal to half of m1 v1 v square plus half of m2 into v square, because after collision both of these start moving with the common velocity, right? So now E2 is half of m1 plus m2 into v square, right? This is equation number 1, this is equation number, okay, इसको 2 ले लेते हैं, इसको 3 ले लेते हैं, क्योंकि 1 हम ऑलरेडी यूज कर चुके हैं कॉमन वेलोसिटी के लिए. नाउ वी वांट टू कैलकुलेट E1 माइनस E2, और हम E1 माइनस E2 को क्या प्रूव करेंगे? ग्रेटर देन 0. सो हाउ यू कैन कैलकुलेट E1? E1 इज हाफ ऑफ m1 u1 स्क्वायर प्लस हाफ ऑफ m2 इंटू u2 स्क्वायर माइनस हाफ ऑफ m1 प्लस m2, और v हमने कैलकुलेट की थी यहाँ पर, v इस रिलेशन से इक्वेशन नंबर 1 से m1 u1 प्लस m2 u2 डिवाइड बाय m1 प्लस m2 यहाँ पुट करेंगे. दिस इज m1 u1 प्लस m2 u2 का होल स्क्वायर डिवाइड बाय m1 प्लस m2 होल स्क्वायर, right? One of the square get cancel out, half you can take common, this become m1 u1 square plus m2 u2 square minus of, I will open the square, m1 square u1 square plus m2 square u2 square plus 2m1 into m2 into u1 into u2 divide by m1 plus m2, right? Now we will take its LCM, m1 plus m2, and it become, इसको मल्टीप्लाई करोगे फर्स्ट टर्म को दोनों से, m1 स्क्वायर u1 स्क्वायर m1 इंटू m2 इंटू u1 स्क्वायर, इस टर्म को दोनों से मल्टीप्लाई किया. नेक्स्ट m2 m1 u2 स्क्वायर m2 स्क्वायर u2 स्क्वायर, राइट? अब ये टर्म एज इट इज खोलेंगे विद नेगेटिव साइन, माइनस m1 स्क्वायर u1 स्क्वायर माइनस m2 u2 स्क्वायर, वन टर्म इज देयर माइनस 2m1 m2 u1 इंटू u2, ये इसके बाद वाली टर्म है, ठीक है बेटे? दिस इज नॉट इन डिनोमिनेटर. सो नाउ यू विल टेक हाफ ऑफ m1 प्लस m2, and this term it get cancel out with this also get cancel out with this. तो ये आपका m1 इंटू m2 इन सब टर्म्स में से क्या आ गया? कॉमन, इसमें से और इसमें से, तो ये बन गया u1 स्क्वायर प्लस u2 स्क्वायर माइनस 2u1 इंटू u2, राइट? तो यू कैन राइट दिस एज हाफ ऑफ m1 इंटू m2 डिवाइड बाय m1 प्लस m2 इंटू u1 माइनस u2 होल स्क्वायर. सो व्हाट इज दिस? E1 माइनस E2. ये हमने क्या कैलकुलेट किया? E1 माइनस E2. नाउ व्हाट इज दिस? अगर ये हमेशा आपकी, दिस इज अ परफेक्ट स्क्वायर, दिस टर्म इज ऑलवेज पॉजिटिव, दिस टर्म is always positive. When this term is always positive, this means E1 minus mass never be negative, m1 never be negative, m2 never be negative. If it is negative तो इसका स्क्वायर क्या हो जाएगा? पॉजिटिव. This means E1 minus E2 is greater than or equal to 0. This implies E1 is greater than or equal to 0. Sorry, E2 अगर आप इधर ले आते हैं, this is E1 is greater than or equal to E2. This means kinetic energy before collision is, या आप ये कह सकते हो, this is kinetic which is always positive. अगर इसकी velocity होगी, यहाँ equal to भी मत करिए, it is always a positive. E1 is greater than E2, इसको आप 0 मत करिए, it is always positive, right? So kinetic energy before collision is greater than kinetic energy after collision, right student? You can write it at is greater than 0, means it is always positive. So we have proved in perfectly inelastic collision there is some loss of kinetic energy. I think it is clear to all of you. Thank you, have a nice day. In the next video I will discuss elastic collision in 2 dimensions. Thank you.